line inclined to both the planes, that projections. Okay. Line inclined to both the planes. First I will explain the concept how we can draw the line inclined to both the planes projections. Right? For that, consider this is a small instrument which I have prepared, and here this board we can consider as horizontal plane, right? And this is the straight line. Now what we can say, a line is parallel to VP and inclined with HP. Okay, the line is parallel to VP and inclined with HP. Suppose the same line, if it is rotates like this. Now what we can say, the line is inclined with HP and line is inclined with VP also, right? If this is the line position, how we can imagine, how we can draw the projections, that is front view and top view. Okay, now to reach this position, two possibilities are there. One is, first consider the line is parallel to both HP and VP. First consider the angle with HP, that is theta. Okay, after that consider the angle with VP, that is phi, right? Second one, first line is parallel to both the planes. First consider angle of inclination with VP, after that angle of inclination with HP. Okay, in both the cases the final position is same, but two approaches we can derive for this, right? Based on these two approaches, we need to draw some of the conclusions. Based on conclusions, if we overlap the projections of first orientation and second orientation, we got the line is inclined to both the planes. For in that position or in that line, how we can draw the respective projections, we can see, right? Now here I want to assume that, see, for all line inclined to both the planes, I will use, if I am right, small a, small b, that indicates the top view of the respective line, right? Next, if I draw and write a dash, b dash, that indicates front view of that line. Next, if I write theta, inclination with the horizontal plane. Next, if I write phi, this is the inclination with vertical plane, right? These notations we need to remember. Now we will consider a problem like this. A line AB, the capital letters, this gives us original true dimensions of the line AB. A line AB is inclined to HP theta, inclined to VP pi, and lower end is above HP. Lower end is above HP and in front of VP. Okay, these are given in the problem, right? In this case, how we can analyze the problem? First, I will tell you. Here, One is the true length of line. The second one is inclination with HP. The third one is inclination with VP. And fourth one is position of lower end. That means position of fixed point. Now, for this first case, case 1. In the case 1, consider inclination with HP first. That means theta first and phi second. Right. In both the cases, the first step is we need to look at the position of fixed point. Right. Now, this is XY reference line. Right. Position of fixed point. It is above HP. What is the distance given in the problem? That distance you need to consider and draw a line here at a distance above HP. You need to draw. That distance is visible in the front view. That is the reason we consider. Next one. It is in front of VP. That distance is visible in the top view. Whatever be the distance given, that distance you need to consider here. Now, look at the position of fixed point. If we consider a fixed point here, if you project it, this is the other one. Let it be A dash and this is A. Okay, this is A dash and this is A. Now, the line is inclined to HP theta. When it is line inclined to HP theta and parallel to VP, in the front view, true length of the line, true inclination of the line with the HP is visible. Therefore, draw the front view by considering theta inclination. This is, let it be theta inclination and the true length AB. Therefore, this is the line A dash B1 dash. Okay, right. And this is theta. Okay. Now, what will be the top view for this? If you project it downwards, this will be the B point and this is the respective top view. Okay, right. Now, this same line rotates without disturbing theta for pi inclination. Here see, the line is rotating. If the line is rotating, pi is not considered on the horizontal plane, but it is considered on the AB plane, A dash B dash plane. Okay? Therefore, for any angle of inclination, see, if the line, this is like this, right? After that, if it rotates like this, suppose if it is 10 degrees, this one, 20 degrees, this one, 30 degrees, 40 degrees, like this. It will be rotating for any angle like this, right? But the angle of rotation is above in this plane. Okay, that means inclined plane. Here it is, right? Therefore, this angle will not be followed by the top view. Okay, we cannot consider that pi inclination for the top view, right? Now, here one more observation we need to do here. When it rotates for any angle of inclination, what is the position of moving point B? When it is here, this is the position. When it is here, this is the position. When it is here, this is the position. That means a line, a horizontal line, it will be maintained for any angle of inclination with VP. Okay, that we can draw here. See, this is the line we got for any angle of inclination. For any angle of inclination, this is the line we got, right? And the respective pi and inclination with the vertical plane, here we cannot draw. Okay, up to this we will stop here. Now, the second case, case 2. Now we will see. In the case 2, first, as usual in the case 1, draw the XY reference line and look at the position of fixed point. Position of fixed point above HB, in front of VP. And this is the position. This is A dash and this is A. Okay, now first consider pi. Okay, in the case 2, pi first and theta second. Okay, for the final position we need to consider phi first and theta second. Now see, if you consider theta first, that means the line is parallel to HB and it makes an angle of pi with the VP. This is the position, right? The line is parallel to HB and makes theta pi inclination with the VP. In this case, in the top view, we will see true dimensions of the line or true length of the line and true inclination of the line with VP. Therefore, we need to draw top view first, right? Now, see. This is pi and this is the true length, right? Now, consider theta inclination. Suppose if you consider theta inclination, see, the theta inclination without disturbing the inclination with VP, this is 10, 20, 30, 40, like this. Okay? If it is moving like this, it stop, you see, it is here, after that for another angle, it will be here for another angle. Okay? That means if angle increases, okay, this in the top view, it will give a horizontal line which parallel to the reference line. Okay, in the top view means after that we need to rotate like this, right? That means we need to draw a parallel line to a reference line. Okay? This is another parallel line. I draw with yellow to the reference line which passing through the moving point. Okay, here also we need to observe that this is the angle of inclination. If it rotates for theta inclination, the theta is not in the horizontal or vertical plane, but it is on the inclined plane, right? This is B1. This is B1, right? Now, in both the cases, same line we consider. This is case 1, this is case 2. In both the cases, we consider same line. That means the end points position A and B are same in both the cases. Okay? If end point positions are same, then respective position we need to find. See, whatever be the angle of inclination made by the line theta, the end point must be lies on the locus line of this. And in this case, whatever be the angle of inclination with the vertical plane, that is pi, the end point B must be on the locus line here, right? Okay, now how we can get that one, right? Now I want to take this one and I want to overlap it, right? Now we know the A, position A, and that pi I want to consider here to distinguish it. The same color white I can use. This is true length and pi, and this is the locus line. I draw this here. Okay. Now, whatever be the angle of inclination which will be, end point must be on the locus line, this one. And what about length? That length is equal to this one only, B. Okay, this end point is length equal to this one only. Okay, that only it will rotate like this, right? Therefore, we need to rotate like this. Okay, na? Right. This is the required top view. This is AB. This is the required top view. I want to show with yellow. Required top view. And if you see the angle of inclination, this is more than 5. And that is the reason this is called as apparent angle. We can call this as the beta. That is beta. Now, I want to take this and I want to overlap here, right? This is the locus line. Just I will consider the locus line. That means this is the true length. First we need to draw true length with a true angle of inclination theta and draw the locus line here, right? And here pi already is there. For any angle of inclination with HP, the moving point end lies in this locus line only. Okay, if it rotates like this, like this, like this, this on this locus line only it will lies. If you project it, this is the respective front view, and this is the length it is rotates and final position it will give, right? Therefore, rotate it. And if you draw a line in between these two, this will give us a final front view. This is B dash. And this is also angle which is more than theta. It is called as apparent angle alpha. Right. And here, this is the moving point top view. This is the moving point front view. Okay, but the moving point B is same and it is the end point of AB line. Therefore, if you draw a line from B dash, that means if you projected B dash downwards, okay, the point obtained here, and if you connect these two, this length and this length must be equal. Then only our projection is correct. Right, this is B. because B represent same point. Okay, B dash represents same point. Here also, this is the top view, and if you project it upwards like this, it must be B dash, because here also the same point. Then this is B dash, right? Okay, what we conclude from these two? Now, for the conclusion, first consider the line with the true lengths, true angle of inclinations with theta and pi. Locate the fixed point and draw the true lengths in the front and top views. In the front view, consider theta angle, and top view consider pi angle, right? After that, at the moving points in the top view and front view, draw the locus lines. After that, project it downwards and rotate it up to the cutting of locus lines. Okay, and if we draw the respective lines, that will give us required front view and top view, right? Now, I want to summarize and I want to give a clarity on this so that student can remember very easily the projection of line which is inclined to both HP and VP. Now we will see the problem as usual. Here, a line AB is inclined to HP theta and inclined to VP phi. The fixed point or lower end above HP and in front of VP. Draw the projections of the respective line. Okay, this is the given problem. Now, to draw the projections, that means front view and top view, first draw reference line XY. Locate the position of fixed point A dash and A. After that, consider theta inclination with HP. This is theta inclination with HP. This is theta, right? And this is the other end. This is not the final front view. That is the reason I want to show with B1 dash, right? After that, by considering true length and true inclination with VP, that is phi, this is pi, okay? And this is B1. It is not the required top view. That is the reason I give the notation as B1. Now, draw the locus line. This is the line which is parallel to reference line and passing through moving point B1. Okay? Here also draw the locus line in the top view. Okay. Now, project the B1 dash downwards up to a horizontal line which is passing through the fixed point in the top view. Once again I repeat the same thing. Project the B1 dash downwards or project the moving point in the front view downwards up to a horizontal line which is passing through the fixed point in the top view. After that, that fixed point A is center rotated. Okay, that will cut the locus line, right? Now, If you draw a line in between these 2 points, that is the required top view. This is B, this is A, this is B. That is the required top view. Now, for the front view, similarly, project the moving point in the top view upwards up to a horizontal line which is passing through the fixed point in the front view. After that, rotate it with A dash as center up to cutting off locus line. Okay, up to cutting off locus line in the front view, right? Okay, now if you draw a line in between these two, that will give us the required top view and name it as B dash. This is A dash, that is B dash, right? Now you can measure the respective apparent angles. This is alpha, this one is alpha, and this one is beta. Apparent angle alpha and beta. Okay, and one more observation we need to do. If you draw a line in between this B dash and B, this is the line perfectly a vertical line and perpendicular to the reference line. Okay? If you are not getting this line perfectly, your projection may be wrong. Right? Okay. These are the steps student need to remember. First one, locate the fixed point position. Second one, by considering the true length through angle of inclination with HP and VP, draw the lines in front view and top view. Third point, you need to draw locus line through moving point in the front view and top view. That locus line is perfectly horizontal line or parallel to reference line. Now, fourth point is project the moving point in the front view downwards up to a horizontal line which is passing through the fixed point in the top view. After that, that fixed point as center, you need to rotate it. That will cut the locus line in the top view, and that cutting point and if you draw a line, that is the required top view. Next point, if you project the moving point in the top view up to the horizontal line which is passing through the fixed point, after that, with the fixed point as center, if you rotate it, that will cut the locus line. And if you draw a line in between these two, that will give us a required top view, right? These are the steps student need to be remember. Now, I want to give some observations for this. Here, this line is the projector of moving point. Okay, this line is the projector of project line of moving point. Right. This line is the projector of fixed point. Projector of fixed point. Right. Next one. This to this. This is the distance in between end projectors. Sometimes in the problem itself, it is giving like that. Okay, distance in between end projectors. If it is given, we can draw the end projectors first. After that, the distance, the position of fixed point if it is given. That means you can draw this line, we can draw and projectors. Therefore, this point and this point is obtained directly. The final front view and final top view are required. Front view and top view we can get. After that, it is asked to find what is true length of the line and true inclinations made by the line with HP and VP. We can find very easily. Right? Now we will see different varieties of problems. Right? A line AB, 50 mm, line AB, 50 mm length, makes an angle of 45 degrees with HP and 30 degrees with VP. The lower end above HP, the lower end A, lower end A is above HP 10 mm and in front of VP 15 mm. Okay, draw the projections. Now for this problem, true length is given and fixed point position is given and true angle of inclinations with HP and VP are given. Okay, for this problem, see, draw the XY reference line first. As per step-by-step procedure, locate the position of fixed point. It is above HP 10 mm. Okay, it is above HP 10 mm. Therefore, you can draw a horizontal line above reference line at a distance of 10 mm. This is 10 mm. Right. The line is in front of VP 15 mm. The fixed point in front of VP 15 mm. Therefore, you need to draw a horizontal line parallel to XY reference line at a distance of 15 mm. 15 mm. Okay. Now, the position of respective line or fixed point is, this is A dash and this is A. Okay. This is the projection line. This is A dash and this is A. Now, by considering true length 50 mm and true inclination with HP, okay, this is 45 degrees. This is 45 degrees and true length 50 mm. Let it be here. Okay, and draw the locus line for this. Okay. Now, by considering true length and pi inclination with VP, VP inclination is visible in the true inclination is visible in the top view. Okay, 30 degrees. Right. This is 30 degrees. And this is B1 dash and this is B1. Right. Now here also we need to draw the locus line. Okay. Now project the moving point in the front view downwards up to the horizontal line passing through the fixed point. After that, this AS center, rotate it. Okay, you got a cutting point at this here. This is B, and if you draw a line in between these two, this is the required top view. Now, for the front view, project B1 up to a horizontal line which is passing through A dash Okay, that A dash as center rotated, it will cut here. It will cut here, right? And if you draw a line in between these two, this will give us a required front view. This is B dash. Okay? For the sake of cross check, you can draw a vertical line. It must be perfectly vertical and it need to be passing through B dash and B exactly, because it represents the same moving point, right? After that, the student required to show this as alpha and this as beta. Okay, this is